Hi, good evening. Can you hear me?
Yeah, good evening.
Yeah, how are you?
I'm doing good. How about you, sir?
Yeah, Alhamdulillah, I'm fine. Thank you. Yeah.
Mashallah. Okay.
Okay, so I already developed your code for above ground biomass estimation, and I also
Okay.
try to add also correlation with
Okay.
bioclimatic variable. Okay. So let
Okay.
me share my screen and then show you all of details step by step. So just a minute. Okay, can you see my screen?
Not yet. Yeah.
Okay. Okay, so this one in this code I try to okay. First of all, I try to show you that. Okay, so this is the output or result. So in this time, first of
Okay.
all, this is our variable importance for random forest model. So we
Okay.
can easily find out this type of chart, variable importance from random forest. And then we calculated that root mean square error. Okay, mainly our ground data and also satellite data above ground biomass. Okay, just comparison. And we find out the root mean square value, this type of value we find out, and then
Okay.
mean absolute error we find out, and also calculate
Okay.
the r square value. Okay, basically
Okay.
between the above ground biomass, between ground data and also
Okay.
satellite based data. Okay, after that we make the correlation. Suppose correlation between above ground biomass and bioclimatic variable 01. Okay, so then we find out this type of result. Also you can see it's a Pearson correlation. Okay, then with this type of things further we also display as a chart, and then it look more better, but this is the statistical value for
Okay.
correlation between above ground biomass and bioclimatic 4, then correlation between above ground biomass and 5, then 6. Okay, then 8, then 12. Okay, then 13,
Okay.
then 14, then 15, then 18. And this thing we also try to develop as a chart. Okay, bioclimatic variable and also above ground biomass. Okay, we create this
Okay.
type of chart, so we can also add this type of chart in your paper. And in
Okay.
this time it's not the proper way. When you want to make the chart for your paper, then we try to use this type of chart. Okay, this type of chart. So for that I
Okay.
also try to develop this code using Python also. Okay, because
Okay.
this type of chart we can easily display. Okay, so it's a more appropriate for your
Mm-hmm.
paper. Okay, so bioclimatic variable for so different variable by 1, and then 4, then 5, then 6, and then we just check the correlation with our data above ground biomass, and we find out this type of chart. Okay, so
Okay.
basically this is a similar chart. This type of is a similar chart, but Python we can easily get this type of chart, all of chart at the same time. We just make the one frame.
Better.
Okay, so then okay,
So I have a question.
yeah, please.
So about the correlation, it's not possible to display it like a map.
Map, yeah, so we can also display the heat map also. Okay, so if you check this is,
Not
yeah,
okay. The heat map. Okay.
yeah, correlation heat map between above ground biomass and bioclimatic variable. So we can display the result, this type of heat map, and we can easily represent, okay, this type of heat map in our paper for the correlation. Okay, where is the high correlation, where is the low correlation, this is the reason about the for this heat map.
Okay.
Okay, we can easily represent this type of things, and this chart we can also add in our paper also, and we can represent all of bioclimatic variable and above ground biomass is just correlation heat map we represent. Okay, this type of thing. Okay, then this is another thing. So basically okay, so this one, okay, let me show you that. Just open. Okay, so this value above ground biomass and also others, so it's one kind of heat map. Okay, but in this time in Google Earth Engine you find out this type of heat map without legend, without color. So these things further we try to develop using this way,
Okay.
to adding the legend, other things. Okay, and if you check so in this time variable in our features we just use. Okay, so in this time we also consider also about that our bioclimatic all of variable, we also extract the pixel. Okay, if
Okay.
you want, you don't need this type of things as a training sample, then you simply just run the code without this type of bioclimatic variable. So if you check,
Okay.
I also add in here this one, yeah, this one you can see I also add this type of bioclimatic variables as a features. Okay, so these features mainly all of training some.
Basically, I
Yeah,
don't need it for
yeah,
the
so then
mapping of
then that,
biomass.
yeah, then we just simply remove this thing if not need. Suppose just simply remove from here, you can see add bands. So just I simply comment these things. Okay, bio variable I simply remove. So just I simply add this type of index which you already sent me. Okay, and also
Okay.
combine with the scenario one. So just I simply remove these things, and further just I simply remove this type of band, because I want to train my model only use of sentinel-2 and sentinel-1 data. Okay, so
Okay.
then bioclimatic variable don't need, just I remove, it's not need. Okay, and further we just
Okay.
simply work, it's not problem. Okay, so now I'll try to explain the full code step by step, then you can get the idea. So first of all, this is your training sample. Okay, which stored the above ground biomass, and then we try to maxing the function for cloud maxing and removing the cloud. This is the function about that, and we computed ndvi, okay, evi, and then we try to use at the sentinel-2 collection. Okay, then simply this function we simply connect with our collection and also collect the connection with the cloud max function. Okay, and then we just simply select all of bands, okay, together. After that we just extra vegetation indices also add in here. Suppose t and dvi. Okay,
Yeah.
so for the t and dvi we are just use this equation for t and dvi, and also calculate sdvi1, sdvi2, sdvi3. Okay, so his type of index
Yes.
you add, I also try to add this type of things. And then for the biophysical product we also use at the leaf area index. Okay, so leaf area index we are just use this data set. So if you did simply copy and just simply search here, then you can get all of details about the data source. Okay, this data set we are just use for the leaf area index to get the
Index.
data
Okay.
leaf area index. So then you, when you write your paper, then you also try to check the data source other thing, just simply check this way. And also you
Yeah.
can see this is the another one. So from here we take the another. So this is the another, basically it's called the forest. Let me show you that. Just simply copy,
Mhm. Go
copy,
to the
and
catalog and
yeah, and then we can easily find out this data set information. So basically this one is
okay.
the fraction of absorbed photosynthetic active radiation. So this data we collect from here. Okay, so you also mentioned about this data set also. Then this is the forest cover percentage. Okay, so this is the
Yeah.
forest cover. So this data set we are just used for the forest cover percentage. So you also simply check the data, all of information about the forest cover percentage. Okay, percent tree
Okay.
cover. And then sentinel-1 data we are just use, and we calculate the vs minus vv and vv plus vs, simply do it and connect with our image collection. And for the bioclimatic variable we are just use this data, it also available in the Google Earth engine. So we
Yeah.
simply use this bioclimatic variable. So in the variable you can easily find out all of b10. Okay, so annual mean temperature, all of this you can easily get from here, all of factor.
Yeah.
So just simply we make the list and clip with our study area, and then we simply just normalize this type of scale. Basically this type of value we are just simply multiply with our bands, then it will be normalized. Some
So
climatic.
so it will put
Yeah,
it all band will be in the resolution 10 meter, right?
yes, yes, yes. Yeah.
Where you multiply by 0.1.
So this one is the scale value. If you check, I'll show you that. So in this time we also find out the scale value, you can see 0.1. Okay, so in Google Earth engine it mainly show you the result digital number. So when I multiply this value 0.1 or scale value, then it show some, you can some it show the 0. So you don't need for this type of things, it not need. Okay, so you can see some the 0.001. Okay, so which band, which scale, just we simply multiply. So when you multiply, then it show the appropriate pixel value. Okay, we find out
Okay.
the appropriate pixel value. So that's why they also provide this type of scale. Okay, so then we simply use this type of scale. Okay, where we need, then we simply multiply. So then we find out the appropriate pixel value, this type of bioclimatic variables, and further simply combined all of those. Okay, so in this time I am not using the bioclimatic variable, so that's why I simply comment. But if you want, you can also extract the pixel value, then simply uncomment and then also use it, no problem. And then we simply apply the same process for random forest. For that we simply extract the data. Basically we extract the training sample. For that this is our this column. Basically this is the column for your shapefile. Okay, in the shapefile we have a column. It is stored all of ground truth data, so we are just use it as a properties. And further we simply distribute the data. Okay, 70% and 30% training and testing. And then we also check the how much training sample, how much testing sample, also print in here. So then we simply make the features. Okay, and then we put here the random forest algorithm. We apply the regression model, and then we simply explain about our model. So here we find out that all of those. Okay, so all of this can easily find out in here.
Sorry, sir.
Yeah,
I
please.
have a question.
Yeah.
I think last time in my methodology, you have to stack all images, Sentinel-1, Sentinel-2, vegetation indices, and biophysical indices. And after that, you have to extract the pixels values and associate it with the ground truth. I did not see that. I don't know if it's ahead or...
Okay, so now we are just use this type of bands. Okay, so basically we already make the combined image. If you check in this variable, we combined. Okay, we just combined Sentinel-2, Sentinel-1. Okay, so for the Sentinel-2, all of bands we just combine in here. Not only for that, this Sentinel-2, as well as we also create some other index. Okay, so this type of index we also add. Okay, as well as we also add for Sentinel-1 and create the combined image. So we extract the pixel value from this combined image, which have all of bands or all of index available. So this combined variable we are just use and extract the trainings pixel value for our chroma. Okay, so then we simply do it. So these are features. We apply the regression. So now this importance, we also find out this type of importance. But this thing we also just make a chart. Okay, so for that we are just use the code, and we find out this type of chart. Okay, this type of chart. So in this time it also show about the bio 4 or 3, because previous time also added. So when you run it, then this bioclimatic variable is removed. Then we find out only for those bands, no problem. Okay, then okay, so then we just combine, just we simply call the combined image and connect with our model. Okay, RF model which I already created, the random forest model, and I rename it as a this. So now it represents this type of map. We find out this type of above ground biomass map. And then for the accuracy, we are just use here the this type of accuracy, root mean square error, or also calculate about the mean absolute error, and also calculated the your R square value. We just come for the checking the accuracy. Okay, and finally for correlation, we are just
sorry for the accuracy. Last time you sent me a screenshot, the R square were very close to 1. I don't know if
so so in this time we also add the other parameter also, because other bioclimatic variable we also added, so that's why it look like that. So when I run, then it also work, no problem. So in this time this result show when I added. So if you check now, it show about the bioclimatic variable also this. So that's why it look like that. Okay, so just when you remove and then you also find out the accurate result, no problem. Okay, so now we are just make the correlation. So in this time we are just make the correlation. Mainly we are just check the Pearson correlation. Okay, Pearson correlation. So if the R value is the negative, it indicating about that is the negative correlation. Okay, suppose if the above ground is high, then bioclimatic variables are low. Okay, so suppose then if the positive value, we find out the R value is the positive, it indicating about the positive correlation or proportion. Okay, or not opposite. Suppose if the above ground is high, then also climatic variable is also high value, we find out for the positive correlation. And if the R value is equal to 0, it means that there is no correlation, neutral. Okay, so just we are use the code. So first we simply add all of correlation, then we simply just also for our first of all we just calculate the value for each correlation. Okay, negative correlation, negative we find out. Also you can see also, okay, we find out the positive correlation for above ground biomass. Okay, we can find out the positive correlation, it's a negative correlation. Okay, find out the positive correlation, it's a negative correlation. Okay, it's a positive correlation. And finally this type of chart we are scattered chart for each bioclimatic variable we are just represent. Okay, so this column show about the above ground biomass, it show the bioclimatic pixel value, so then we represent. So these things we also just for the proper way we are just use this Python code. Okay, we are just create this type of things to represent all of things. So now how I can create, I also explain about that. So in this time we are just simply import all of Python library, and then we simply import our data. Okay, training data basically in this training data it stored all of index value, all of bands value. Okay, all of bands value, and also have our ground truth value. Okay, you can see it's a ground truth value, it's come from our ground truth value, and all of pixel value for B12, all of bands, as well as also bioclimatic variable. Okay, all of those. Okay, for our specific coordinate or training sample. So this is our training data. So this data I want to set with random forest regression, and also scalar model for selection, and also I want to apply the scalar matrix to check the mean square error or R square error. So this type of things.
Please, I forgot to ask you if it was possible maybe to record our meeting so that later I can review it if I miss something.
Okay.
You can try to record it, please.
Okay. So now we find out this type of things, and then we just simply make the features and target, and then we apply the regression. Okay, and then we create the importance, variable importance. Okay, so in this time it also adding the bioclimatic variable also. Okay, because in this time we just check the correlation with bioclimatic. So just I add in my CSV file add all of those bands also. Okay, and then we check the, you can see we find out this type of value for R square and also RMS value. So basically it's including all of bands, your bioclimatic variable also including all of those. Okay, and then okay, so now only for bioclimatic variable we work, because we just make the correlation for the bioclimatic variable. So just I simply put all of bioclimatic variable column name, and then simply connect with my basically we just apply the pair plot function. It's come from the CNS. This pair plot function it easily provide you that scatter chart. Okay, this type of scatter chart. So you can see bio 1, bio 4, so all of bioclimatic variable we can easily find out, and this type of chart have a value. So this value we can get from here, get from our Google Earth engine, because I already calculate the value. You can see this type of value we can easily get from the Google Earth engine for each bioclimatic variable with the above ground biomass. And then we are just make the correlation heat map. So now we can easily identify for which climatic variable is the high correlation, where is the low correlation, you can easily find out, and also display the value. So this is the legend about the legend. Okay, and this is the bioclimatic variable for each bioclimatic variable. Okay, so this is the full work for you. Okay, so I also send you this code link also, and also send you this code link. Okay, and we can also download the data, GOT file format data. Okay, from here, and further we can easily make the map or other things using here, no problem.
Okay, so please, you're still using the composite image, right?
Yes.
So did you try, as I said, like seasonal?
Yeah, for the seasonal, yeah, if you want you can simply change the season. Suppose year of 2020. Okay, so tell me about your season, then we just put the season.
From April to October, 4.
Okay, 4
to
10.
10th, yeah.
Okay, and also for Sentinel 4 to 10.
Yeah.
And okay, so and also others this type of same. Okay, because 4 to 10. 4 to 10.